what is name node and what is data node. After that, okay, so how the file is stored in Hadoop cluster. Okay, so then okay, key points. This step is key points. Okay, so these are the different things okay we have seen okay last week. Okay, any questions on these three? Any questions on these three? Okay.
Venkat, if you last time we discussed saying if data can be appended but it cannot be changed, means existing content cannot be changed. For that, if we are deleting any portion, let us suppose if any there is
So you cannot delete also, sir. Okay, you cannot delete also. Okay, so here, okay, as I told you, okay, you cannot even delete also. Okay, in between you cannot delete anything.
okay, got
Okay,
it.
yeah.
Mhm.
So it means okay, it is very difficult to make the modifications to the existing file. Clear?
Yeah, clear.
Yeah. Okay. So any other questions on these three things actually? Hope it is clear. Okay. So
if I append anything regarding block under block,
okay.
is then reflected to all blocks, other nodes?
It will go in okay. Other block, right? If you add extra block or extra data, so that will go like a other block only. So okay, so now you are adding something, okay, so that will go in a new block, the data that will not come. Got it?
We are inserting in HDFS only, sir.
You're inserting an HDFS. Suppose okay, if you try to append some data here, okay, if you try to append some data here, okay, so that will go like okay, separate block only. Okay, that will not be added here. That will come like a separate block. Got it? Okay, but don't worry too much about this. Okay, file editions and all. Okay, we'll see. Okay, so the next point is okay, how metadata is maintained by name node in HDFS. Okay, normally, okay, so let us do one thing. So all these days, okay, we understood what is cluster and all, right? Okay, so I will take the same cluster here. I will take the same cluster here. Okay, so okay, so here I'll remove this one. Okay, so these are the different. Okay, so this is the cluster actually. This is our cluster. So I'll remove this one. Okay, so I have total 5 servers. I have total 5 servers. Okay. In each server, okay, I'm starting data node service. I'm calling this as a data node 1, 2, 3, 4, 5. Okay. So it means okay, I have one name node. This is the name node. So this is the name node machine. Okay. And okay, so I have 5 data nodes, one name node and 5 data nodes in the cluster now. Okay. So now Hadoop distributed file system maintains metadata by systems metadata maintained by name node in various files like below. Okay, so what are the distributed files? What are the distributed okay, so system? Okay, so what are the metadata files okay we have in Hadoop or HDFS, and okay, who will maintain those metadata files? Okay, so normally any kind of metadata will be maintained by name node only. Okay, but will it maintain in the same file or get different files? Okay, that we will see now. Clear? Okay, so in the previous example, we have already seen two reports. What are the two reports? What are the two reports?
Centralized fat and data
Exactly.
node information.
Exactly, sir. Okay. Centralized file allocation table is one. Okay, just 1 second. sorry, this looks like okay, some students are still facing issues. Okay. Okay. So name node will maintain two files here. Okay. So one is centralized file allocation table and data node information. Okay. What is this file, guys? Centralized file allocation table. It's a metadata about okay, each and every file you store on STFS, correct?
Yes, sir.
So here, okay, so I have BLK. So here, okay, where is this one? This is the one. Okay. Okay. So BLK001, one copy, one copy, one copy here. So this is BLK001. Okay. So this is BLK002. BLK002. BLK003. Okay. So these are the blocks actually. These are the blocks. Okay. So these two blocks. Okay. So sample one, these two blocks are first two blocks are related to sample1.txt. And okay, the third block BLK003 is related to what is it? Related to second file. Correct or not? Second file is sample2.txt. Okay, sample2.txt. Okay. So these are two files, and okay. So this, hope okay, you understood what is centralized fact. Centralized fact is a metadata table which contains all the files information. All the files information. All the files which you store in HDFS. Any file you store into HDFS, that will be divided into blocks, and blocks will be stored across different data nodes. But okay, so the main file name and block numbers, okay, so this one will be maintained in the centralized fact. Okay, so now who will maintain the centralized fact? Who will maintain the centralized fact?
Name node.
End of the day, so name node is the one who will maintain the centralized fact. Centralized fact file is maintained by name node. Okay. Okay. Centralized fact, okay, is a name, okay, which we have given to understand, okay, ourselves. Yes or no? So why I am using the word centralized fact? Okay. So in case of normal hard disk, okay, you will have normal fact. Okay. So here in distributed means, okay, it's just centralized fact. That is what, okay, we thought. Okay. But okay, so shall we give some technical name for the centralized fact? Huh? See, normally when a kid is born, okay, so what they will call, okay, Chinno Buji, okay, like this they call, okay, but he will have original name, right? Yes or no?
Yes.
Okay, so in the
Yes, sir.
same way,
Yes.
okay,
Yes.
so in the same way, so let us change the centralized fact to a correct name. What is the proper name? This one, okay. So the proper name is nothing but your first image, okay. So the correct name, okay, going forward, okay, I will not call it as a centralized fact, okay, I will call it as a first, okay, image. Understood? Understood, guys. Okay. Moving forward, I will not call this as a centralized fact. Okay, I will call it as a FS image. FS image. Okay. Clear? Any questions?
Okay, sir.
Hmm?
Yes.
Okay. So FS image is nothing but your centralized fact. Okay. So what information a FS image will contain? So FS image entire file system metadata, which includes all the file properties like file name, ownership, permission, timestamp, size, replication factor, and list of blocks stored in the file in a file called FS image. Okay. So entire file system metadata, entire distributed file system metadata will be stored in the FS image. Okay. Will be shared in the FS image. Okay. But there is another file, guys. There is another file which is called as edits. Okay. So what are these edits here? Is this edits here? Okay. So now I'm saying that, okay, so there is another file which is called as edits. Okay. Edits. Okay. This is the another file. Okay. Edits also will have the same structure like this. Understood, guys? Edits also will have the same structure like this. Understood? Any questions? Understood? Or any questions? Okay. So now you may ask me a question, sir. Okay, why edits then YFS image when they both have same structure? Huh? When they have same structure, why separate FS image? Why separate edits? This is the next question. Okay. So now the question here is that, okay, let's say Hadoop cluster. Okay. How many people will use this Hadoop cluster, guys? Normally, how many people will use Hadoop cluster? 10 people, 100 people, 200 people.
So many.
Huh?
Actually, based on requirement.
Okay. Suppose, okay.
Based on data nodes.
No, it is not based on data nodes and all. Okay. Suppose, okay. If normally what information we store, okay. Suppose, okay. If your bank is creating a Hadoop cluster, okay. What information bank will store inside that Hadoop cluster? All the customer transactions, correct? When is a customer transactions, what are the customer transactions? So what you deposited, okay. So whatever account statement you are generating, okay, from where that account statement is coming, guys? Have you ever thought of that? You are generating some account statement, right? You want to see last 1 month transactions. Okay, end of the day, from where the data is coming. Suppose, okay, you have Axis Bank account. Okay, so what Axis Bank will do? So Axis Bank is a big bank. Okay, so it is not possible to store all Axis Bank data into a database. That is the reason they created one Hadoop cluster. So they store all their data into Hadoop cluster. So any customer transactions, okay, let it be deposit, withdraw, okay, online transfers, okay. So anything, loans information, insurance information, okay, understand? Okay, credit card information. Okay, so all this information will be stored into Hadoop cluster. Okay. Now, as a customer, will you access the data or not? Huh? Will you access the data or not? Okay. How will you access that data? How will you access that data? So, as a customer, okay, so you will access the data using, okay, internet banking actually. So you will log into internet banking and, okay, you will go to respective page and, okay, you will select, okay, account statement and, okay, you will select start date and end date and submit or, okay, show transactions. Immediately it will show all the transactions you made. But end of the day, that information is coming from where? From the Hadoop cluster. Okay, so it means, okay, thousands and thousands of people will be connected to name node. Okay, will be connected to Hadoop cluster. Thousands and thousands. Okay, but okay, think like this, guys. Okay, think like this. Okay, so this name node, okay, will be able to write the data with some speed. Okay, so let us take okay, so not able to write data into speed. Okay, so let's say, okay, so customer one, okay, user one is writing sample 1.txt. Okay, so what is the process here? What is the process here? What is the
Writing
process?
algorithm will
Okay. So when user one, okay, so first, okay, run the command. User run the command, correct? User run the command. Okay. So what will happen? Okay. Command will invoke writing algorithm. Yes or no? So writing algorithm. So I will put it in WA. Okay. So writing algorithm, okay, connects to name node and okay, check for the okay, request for file read. Request for new file write. Yes or no? Okay. What name node will do? Name node, okay, checks in the metadata. Checks in the metadata whether the entry is existing or not. Whether the same file existing or not. Okay. Yes or no? Name node checks in the metadata whether the same file is existing. Okay. So now, if name node service want to check, okay, whether the entry is existing in this file or not. Okay. So name node has to open this file and check it, right? Without opening a file, can I check any data?
No, sir.
No, right? Okay. So So this is what, okay. So name node is opening this FS image file. Correct or not? Okay. Opening, okay. So it's the metadata. So open. So name node opens. Okay. Metadata. So here, okay. Centralized path. Otherwise, okay. So here, okay, FS image opens FS image and checks. Okay. And check for the check whether the same. Okay. Name node opens FS image and check whether the same file entry existing or not. Yes or no? Will you agree with me? Name node is opening this one, opening this file, okay, and checking whether the entry is there or not. Okay. So fine, okay. If yes, okay, okay, then okay. So it will say already file is there. If no, then what it will do? So name node will confirm, okay, okay, okay. Writing algorithm, you start writing the data. Okay. Next writing algorithm will do some steps, okay, and write the blocks and all. Okay, finally, what will happen? At the end, after a few steps, name node again opens first image, okay, and update the new files metadata. Or not?
Yes, sir.
Okay, metadata. Suppose, okay, so if you are writing sample3.txt, okay, once all the blocks are written successfully, immediately name node will put extra entry. Third, okay, number 3, sample3.txt. So block size this one, okay, all this information will be updated here. Okay, it means, okay, name node open FS image, update the new file metadata, and close the FS image. Will you agree with me?
Yes, sir.
So it means, okay, so if one user run a command, it follows these many steps. Yes or no?
Yes.
Yes or no? So for every user request, for every new file write operation, name node is opening a first image. Right. Okay. But what in case, okay, here only one user is running a command. Okay. Let's say there are, okay, 1,000 users, okay, running their commands at a time. Understand? There are 1,000 users running a command. Okay. Running similar. Okay. So they may not be writing the same file, but okay, they are writing different files. Okay. Different files. Okay. But okay, 1,000 users are writing 1,000 different files. Okay. So for each user, the process is same or not?
Yes, sir. It's same.
It is same. Okay. And okay, 1,000 users are doing 1,000 different files. Okay. So it means, okay, for each user, name node has to open the first image one time. Yes or no? Okay. But if 1,000 users, okay, if they do one after other, okay, in a sequence, that is fine. Okay. But are they coming in sequence? No, right?
No, sir.
No, okay. They're all coming at the same time. It means, okay, everybody's request is important for name node. Okay. So now if 1,000 users comes at the same time to write 1,000 different files, okay, name node, okay, but we have only one name node, even though we have 1,000 users, but okay, how many name nodes we have? Only one name node. Okay. So one name node has to manage all 1,000 users request or commands. Yes or no? Okay, so now name node has to open this file 1,000 times parallelly. Okay, can you open, okay, a single file 1,000 times parallelly? What will happen if you do this? What will happen?
Performance issue.
Huh?
Some performance issue.
Okay, it may be performance issue. Correct? Okay. See, one thing is that, okay, performance issue. Opening the same file. Okay, see, yes, okay, see, multiple users, okay, can open the same file, and okay, so multiple times, okay, one file can be one file can be used by multiple times. Okay, that is not a problem. But okay, but 1,000 people are opening it, are trying to do, and okay, anybody is trying to open this file 1,000 times. Okay, then there may be one reason is performance issue. Okay, other reason, what is the other reason? Okay, suppose, okay, now, okay, today I have written only 2 files. Okay, so normally when I say Hadoop cluster, okay, you will be writing lakhs and lakhs of files. Okay, crores of files you will write. Okay, let's say if I have 1 crore file, 1 crore file, how many entries I'll have in FS image? you stored 1 crore files. Okay, here. How many entries I'll have in FS image?
1 crore.
1 crore entries. Because okay, every file will have one metadata entry, right? Guys, okay.
Yes.
Are you following me or not?
Yes, sir.
Yes, sir.
So every file, whatever file you write here, okay, that will have one entry here. Now I have written, okay, 1 lakh files I have written, sir. Okay, 1 lakh files. So 1 lakh entries will be there inside FS image or not?
Yes, sir. It will be there.
Yes, sir.
So I have 1 lakh entries inside FS image. 1 lakh files metadata will be available here. Correct. Okay. Now, okay, when okay, FS image is growing to 1 lakh, definitely the size of FS image may increase, right? If FS image is having only 2 entries, okay, maybe FS image size is 1 MB. 1 MB. Okay. But if FS image is having 1 lakh entries, okay, this may go to 1 GB also. Yes
Yeah.
or no?
Yes, sir.
Yes, sir.
Okay. It means, okay, the more and more metadata you store, okay, the size of FS image will be increasing. Okay. So if it is a small file, opening 1000 times may be easy. But okay, if it is a big file, when you try to open 1000 times at a time, okay, don't you think, okay, there will be a chance of corruption? Huh?
Yeah, obviously, sir.
Obviously, yes. Okay, there will be chance of corruption. Okay, so if FS image is corrupted, if centralized metadata file is corrupted, okay, is it okay?
No, sir.
This is very, very important file, right? Huh?
Yes. Yes.
This is very, very, very important file. Okay, so you lost this file means, okay, almost, okay, you lost everything in Hadoop cluster. It is like a heart of your Hadoop cluster. Okay, heart of your Hadoop cluster, and you need to safeguard very well this file. Okay, so it means, okay, the more and more files you write into Hadoop cluster, the more and more entries will be adding to metadata entries will be adding to FS image. When more and more metadata entries are adding to FS image, obviously the size of FS image will grow. Okay, so one fine day this FS image may reach, okay, 1 GB, 2 GB, 10 GB, 20 GB, 30 GB, 100 GB also. Understand? Okay, we have FS image almost 600 GB. FS image itself, metadata itself is 600 GB. Okay, so when you have metadata itself 600 GB, okay, opening 600 GB file, okay, 1000 times, okay, there is high chance of corruption. Okay, that is the reason of what Hadoop team has done. Okay, while developing the software, they thought that, okay, opening this big file, okay, many times will lead to corruption of this file. If this file is corrupted, gone case. That is the reason. Let us add one more file with the same structure. Okay, with the same structure. So the idea here is that, okay, initially whenever you are writing a new entry, new files, the new file metadata will come here. So you are writing file 3 now, file 3 and file 4. Okay, file 3 and file 4 directly will not be, metadata will not be written here. Understand, guys? Huh? Understand?
Yes, sir. Yes, sir.
Yes,
Okay.
sir.
So file 3, file 4 metadata will be written here. But okay, this metadata will be appended, okay, with the FS image, okay, every year or once. Understood, sir? Huh?
Sorry, sir. Repeat again.
Okay. So what will happen? Okay, let's say you are writing, okay, now, okay, you are writing file 3 and file 4. Okay, file 3 and file 4. Okay. But earlier, what I told, okay, so whenever I am writing any data, it will be written, the metadata will be updated directly here. Correct or not?
Yes, sir.
Yes, sir.
Okay. But now what I'm telling, okay, so I am introducing a new file. Okay, edits is a new file. Okay, what it will do, what name node will do now, whenever, okay, there is a metadata, whenever there is a new file write process, okay, here name node opens FS image and update the new file metadata and close FS image. This is what, okay, I'm telling, right? But I'm making a change to this statement. Okay, so name node opens this file and update the new file metadata and close edit file. Understood? This is my new statement now. Okay. Whenever a new file is getting written, name node will update that metadata into edit log. Okay. So why edit log here? Because, okay, so edit log is very small file. Edit log is very small file. Okay. So here, okay, I'm putting it everything here. Okay, but actually this is the main file, right?
Yes, sir.
This is
Yes.
the main file. Okay. But okay, so what we are using this edits, okay, edits is kind of a staging area. Okay. Before we load a metadata into here, but we are loading into here first. Okay. Every 1 hour, what I'm doing, okay, every 1 hour, I'm taking, okay, whatever entries I have in edit log, I will, okay, move means and paste here.
But how lookup will happen in this case, Venkat? Because
What lookup will happen? Okay. So in this scenario, suppose, okay, so okay, in this scenario, what will happen? So here, okay, sample, okay, so here, okay, sample 3 you have written, sample 4 you have written, sir. Okay, sample 4 you have written. Okay, the block numbers will be definitely different. Okay. So block number 4, block number 5. Okay, so these are the new file which you have written now. So the new files metadata is here. Okay, and these are the old files metadata. Understood? New files means like recently written files. What do you mean of new file? Just now you have written. Okay, so all the new file entries will come and sit inside this one. Okay, so now every 1 hour, whatever is here, it will be moved to here. Understood? Move. It means, okay, when I say every 1 hour, edit log will become empty. Can I say every 1 hour edit log will become empty?
Yes.
Yes, sir.
Yes, right. Okay, it means, okay, inside edit log, okay, only last 1 hour metadata will be there. In last 1 hour, if you write 10 files, only that 10 files metadata will be there.
So in case of reading algorithm, then
Okay, I will come to that part also, sir. Okay. So in case of reading algorithm, what name? Okay, so the user will write the command. Okay, that command will invoke the reading algorithm. Reading algorithm will contact name node. Okay. So what name node will do now? Now name node knows that, okay, it has a metadata in 2 files, fs image and edit log. Okay. So edit log is always small file, right? Yes,
Yes,
sir.
sir. Yes, sir.
Every 1 hour it will become empty, sir. So it means, okay, so suppose, okay, so what will happen? Okay, let's say time is 8 o'clock now. Okay, 8 o'clock. Okay, so at 8 o'clock is 0. Okay, 8 o'clock it is 0. Okay, so but 8:59. 8:59. Okay, so I may have, okay, let's say there are, okay, 100 new files written. 100 new files written. Okay, so now fs image. Okay, so I will put, okay, edit log, fs image, everything. Okay, so here, okay, so edit fs image. Okay. Initially, edit log also 0, 0. Initially, when I start my Hadoop cluster first, okay, so both will be 0, 0. Nothing is there. 0, 0 means no entries. Okay, no metadata entries inside this table. Okay, so think like this, guys. Okay. Now, okay, now time is 8 o'clock. 8 o'clock. Okay, at 8 o'clock. So 8 o'clock. Now time is, okay. Okay, this is 8 o'clock stages. Okay. Now time is, okay, 8:59. Okay, 8:59. Okay. So whatever the new entries come here, okay, where they will come? Will they come in FSML or edit log?
Edit slug.
Okay, let's say. So from 8 o'clock to 8:59, there are 10 files, new files written. Okay. So it means, okay, 10 entries will be available in the edits. So
Yes.
10 entries will be available in the
Edit.
edit log. Okay. Now time is 9 o'clock. What will happen? Now
Edit logs will be 0, sir.
All 10 files, they are moving to FS
FS
image.
image
Will
has
move to FS.
10 files.
so FS image will have 10 and, okay, edits will have 0.
Yes.
Yes or no? Okay.
Yes,
Now
Yes,
time is,
yes.
okay, 9:59. 9:59. Okay. So let's say there are, okay, 25 edits. It means, like, what do you mean of 25? identified new files.
New files.
New files okay, created on HCL. Okay. Now time is 10 o'clock. Okay. So 10 o'clock. Okay. So what will be the content of edits and what is the content?
0.
Here 0,
Zero,
FS
35.
image 35.
Sir, who is this making a lot of noise, sir?
But Venkat, actually, see, problem is not resolved because anyhow, this edit file need to be opened, not edit, FS image need to be opened to check whether file exists or not. If it is not
Yes.
existing, then only it will go for edits. Yes.
No. First, okay, it will check in the small file.
Okay.
Who knows? Okay, you may be accessing a recently created file, right?
Yes.
So
Yes.
checking, okay, see, checking big one and coming to small one is better, or first check in the small one, then going to big one is better.
Small one is better. Yes.
So first check in the small one first. Okay.
Mhm.
If it's available here, you take it from here itself. Now,
Okay. Okay. Got
if
it.
it's not there, okay, then okay, you go in, okay, go and check there. Okay. So one fine day, you know what will happen, sir? Okay, one fine day, okay, edits may be 0. Okay, FS image will reach 1 lakh. Correct or not?
Yes. Yes.
Okay, it means okay, FS image size will be growing every 1 hour. Correct or not?
Mhm. Yes.
Okay. So edit log, okay, but edit log also will grow every minute, but okay, it will go only next 60 minutes. After that, okay, edit log will be merged with FS image. Are you clear?
Sir, edit log is customized time, the time.
Huh? That okay, 1 hour can I customize? That's what you're asking?
Yeah, yes, sir. That is it a customized.
Of course, yes, sir. Okay, you can customize. 1 hour time, okay, you can customize. Okay. So you want to merge edit log content, okay, every 30 minutes. Instead of waiting, okay, 1 hour means 60 minutes. Instead of waiting for 60 minutes, okay, if you want to merge it with the FS image every 30 minutes, then okay, you can set it in the configuration.
Sir, what if edit log gets full before
There's
the
no
time?
concept of edit log fully. Is it a predefined size edit log, sir? No, right?
Yes.
Okay, so it is a file. You keep on writing.
Okay. Like what is the percentage of edit log compared to FS image?
Sorry.
Like what is the comparison, like size comparison with FS image?
Sir,
It will
you
be
can compare, right? Okay, so this edits will have only last 1 hour data. Okay, but okay, so let us take this scenario. Okay, we built a Hadoop cluster, okay, on 1/1, okay, 2015. Okay, 1/1/2015. Okay, so how much data will have in the edit log? How much data will be there in the FS image? Tell me. So in the FS image, okay, so edit log means okay, edit log can only maximum last 1 hour data. So what is data for okay edit log? Metadata. Edit log will maintain only metadata for last 1 hour. It means okay, last 1 hour means okay, if this is edit log, okay, it will have data from okay now okay 7 o'clock to 8 o'clock. Correct or not? Okay. Correct or not, guys? Okay, okay. FS image. Okay. FS image will contain data from 1/1/2015, 15, okay, 9:12 a.m. to okay, so 2:28, 20, 22, okay, 7 a.m. Understood?
Yes,
So
sir.
FS image okay, will contain okay metadata from day 1. Sir, what is the big confusion here? Very simple, right? Okay. Sir, instead of opening that big FS image file multiple times, what we are doing, we are writing into a small edit log, and every 1 hour, whatever is there in the edit log, we are taking and merging into FS image. Is it a big deal? Or any difficulty to understand?
It's fine.
Huh?
Sir, it's clear, sir.
Clear, right? Okay, still okay. If you are not clear, okay, I can give real life examples, sir.
It's fine.
We are clear, sir. We are clear.
It is clear, right? Okay, so you don't need any real life example. Okay, fine then. Okay. Okay. So this is kind of a. So instead of entering directly into FS image, okay. So first, what name node earlier? Okay, so earlier, as per earlier scenario, so name node was okay. Name node was directly writing into FS image. Yes or no?
Yes.
So as per our earlier understanding, okay, FS image. Okay. But okay, opening this directly writing into FS image, okay. First of all, okay, is taking time. At the same time, there is chance of corruption. That is the reason what they have done. They introduced, okay, it's here in between. Okay. So name node will write in the edits. Okay. Further, okay, from edits, okay, the metadata will go to FS image. Understood? What the big deal?
Yes.
Okay. So the concept here. Okay. So you understood what is edit log also. Okay. Now let's go here. Rather than modifying the existing FS image every time for every transaction means okay, every new file write. Okay. So name node instead record the new transactions, also called as edits in the edit log for durability. Okay. To be safer side, okay. So name node will write the metadata in the edit log first. Okay. From there, okay, it will be copied to FS image. Okay. So edit log transaction will be merged with FS image on frequent intervals to bring FS image content up to date. Okay. So edit log transactions will be merged with FS image. That means okay, edit log metadata will be merged with FS image on frequent intervals. Okay, that interval will be by default 60 minutes, which is nothing but 1 hour. Okay. So I hope you got a clarity like what is FS image, what is edit log. Okay. The next one is block report or bitmap. The next one is block report or bitmap. Okay. What is this block report or bitmap? Okay. What is this block report or bitmap? Okay. Okay. If you understand this one, okay, we have sample1.txt file. That file is divided into how many blocks? How many blocks? How many blocks we have sample1.txt guys? 2 blocks. Guys, please be interactive and please be attentive in the class. Okay, so we have, okay, the sample.txt file is divided into 2 blocks, blk001 and blk002. Okay, so where is blk001?
Data around 1, 2, 3.
Data node 1 to 3. Okay, so now, okay, let's say due to some issue, data node 1 is down, sir. Understood? Due to some issue, data node 1 is down. Okay, what will happen?
Automatically replication will trigger, sir.
Use the replication data.
No, the replication data will be saved to another data node.
Okay. Okay. If data node 1 is down, what will happen?
So it will not
fetch
send.
data from data node 2 or data node 3.
Okay, so it means okay, if data node 1 is down, okay, obviously this block is not available, correct? Correct or not? Okay. So what name node will do now? Name node will create a same block in different machine. So now, let's say it is creating in data node 4. Okay, because this is down, so it created in data node 4. Okay, now this is not there. Now I have 3 copies, correct or not? Okay, now when it is doing this like this, okay, now tell me, okay, is the metadata and actual data block locations are same? As per metadata, block 1 is in data node 1 to 3, correct or not? Yes or no, sir?
Yes, well.
As per metadata, block 1 is in data node 1 to 3. Okay, but actual, okay, but as per as per the cluster, where is the metadata? Where is block 1? Is it in data node 1, 2, 3, or okay, 2, 3, 4?
2, 3, 4.
2, 3, 4. Means okay. So whatever metadata name node is having, is it a wrong metadata, correct metadata?
Wrong.
Sir, but your every 3 seconds this data node will give information to name node so that it will be updated.
Is name node updating here? That's what also point, right? Is name node updating here? Yes, of course. Okay. So if any data node, okay, any new block has come here, immediately data node 4 will report to name node, say that, hey, name node, I have block 4. Okay. So new block BLK001. Okay. But now the question is that, okay, in this scenario, if name node wants to maintain the correct metadata, okay, name node has to update this entry now, update the FS image entry. Okay, it has to put data node 2, 3, 4. Now it is correct metadata.
Yes, correct.
Someone needs to put down 4. This is the correct metadata. Yes or no?
Yes, Venkat.
Yes, sir.
Otherwise, okay, so name node is maintaining wrong metadata. So again, now question is that, okay, so suppose, okay, suddenly if one data node is down, okay, in each data node, you will have millions of blocks in real time. Okay. So for each block, updating the metadata, is it okay?
Sir.
Again, it is a tedious process, right?
Yeah, correct.
Yes or no? So once metadata is written, it should not be touched actually. Okay, but here what is happening? What is happening? Metadata is written, okay, and okay, because of the data node failures, okay, because of the data node adding addition. Okay. So what is happening? The metadata, okay, the new metadata, I mean, okay, the blocks are moving to different data nodes, and okay, so when block is moved from one data node to okay, copied to a new data node, automatically it has to update the metadata here. Means, okay, again it is a challenge to name node. Updating metadata is a big challenge to name node. Okay, that is the reason. So it means, guys, okay, so here today how block 1 is a data node 2, 3, 4. Is there any guarantee that, okay, the same block for block 1 will be available? The same block 1 will be available.
No, sir. No,
in the
sir.
same- okay, going forward also.
Yes.
What is the guarantee, sir? Okay. So now think like this, guys. Now data node 1 is back. What will happen? Now, okay, name node will delete this one. Correct?
Yes.
Yes.
Then again, okay, metadata has to be updated, right? This 4 has to become 1 year.
1.
Or not? So
Yes.
it means, okay, so we don't know that, okay, this block 1 will be here only today. If it is today here, and there is no guarantee that tomorrow also it will be here. Got it?
Yes. Yes.
Okay. So tomorrow maybe means tomorrow it is here means, okay, so tomorrow data node 3 is down. Okay, in that scenario, the same block 1 will be written in block data node 4. There's no guarantee. Okay. So that's the reason. Okay. So since there is no guarantee of metadata, okay. So what name node is doing? Okay, name node is maintaining another report here, guys. Another report. Okay. So what is that another report? So here another report is block number. Okay. Block number. Again, okay. So here okay, there is something called, okay. So block size. Okay. So here there is one more column called, okay, replication also there. Because, okay, we forgot this point actually. Replication. What is this replication? How many copies I want? By default, it is copies. Right or not?
Yes.
Default replication equal to 3. Okay. So it also do the same case. By default, replication equal to 3. Here also the same thing. Okay. So now, okay. So now what will happen? Okay. So instead of, okay, maintaining the data nodes information in the metadata itself, okay. So what I will do, I will remove this, okay, data node information here. Okay. Inside this one, okay, what I will put? I put only the block numbers. I put only block numbers. Understood? Okay. So, okay. So if I put only block numbers, is it fine?
No, sir, it's not fine.
No.
Why?
When reading, because we don't have this one node information. Data node information.
We have, okay, node information like, okay. So suppose, okay, now tomorrow if I want to read the data, so I'll come to name node. Okay, so okay, I will, as a user, I will run the command. My command will invoke the reading algorithm. Reading algorithm will contact name node. Name node will check in the metadata. Understood that it has block 1, block 2. Okay. Now, okay, where is block 1, block 2? Now reading algorithm, okay, has to ask, okay, each server, hey, whether you have block 1 or you have block 1, you have block 1, you have block 1. Yes or no?
Yes.
Yes,
So it is a tedious task. Okay, so that is the reason for what they're doing. Okay, whatever the blocks we have here. Okay, so each block, okay, they are putting it here like this. How many blocks we have here?
5 blocks.
5 blocks. Okay. Now, what is the replication of each block? What is the replication of each block?
20.
Okay. So think that, okay, block 3 also 3. Okay, but block 4 is 1 copy, 1 replication. They want only one replication. They can put, right, whatever number of copies, but okay. So sample3.txt they stored with replication 1 only. Okay, it means, okay, you will have block 4 only in one node. Okay, maybe. So this is the block 4 that is in only one node. This is block 4. Understood? Okay. So I'll put a different color here. This is block 4. Okay, and even, okay, sample4.txt. Okay, what is the block number here? 0.05. Okay, so block 5 may be in only one node. Okay, it may be in this node. Okay, so here, for the size of this one, 50 MB, 50 MB, 50 MB. Okay, understood, guys. Okay. So like this, my blocks are available. Okay. So now, what it is doing here, so whatever the block numbers we have in the FS image file and edit log file, it is putting all the block numbers here. Okay. Along with this one, okay, it is putting the replication factor also. For block 1 and 2, what is the replication factor?
3.
3. Okay. So for block 1 and 2, replication factor 3. For block 3,
Block 3 is 1.
block 3 is 1, sir.
Okay.
Okay. Block 4,
4 and 5 is 1, sir.
huh?
Block 4
1.
1. Block 5 also 1. This is the replication. Okay. So now here, okay. Okay. So now, okay. So it means, okay, this is a report. Now block 1, it is expected in 3 nodes. Yes or no? Okay. So now, okay, if you remember here, each data node will send heartbeat to name node, right? Yes or no?
Yes.
Yes.
Send heartbeat to name node. Okay. In that heartbeat, okay, each data node will tell, okay, whatever the blocks it has. Understand? So what data node 1 will tell? I have block 1 and block 4, correct?
Yes, sir.
So for block 1 and block 4, block 1, it will update like data node 1, block 4, data node 1. Clear? Clear, guys? Okay. Now what second data node will update? Second data node will say, I have block 1 and block 4. Block 1 and block 4. Second data node. Okay. Block 1, DN2, and block 4 also DN2. No, block 4, huh? Block 1 and block 3.
Block
Second
3.
data node. Block 3. Will update block 3. So it means that updating data node 2. Okay. What data node 3 is doing now? Data node 3, how many blocks it has? Block 1 to 5. Okay. So here, block 1 to 5. Okay. So this is DNP. Okay. Block 2, okay. Block 5 also. Okay. And what is okay? Data node 4 is having 2, 3.
Black 2, black.
Data node 2, data node block 3
Three.
also. Now block data node 5. Block 2.
Block number 2, 3, sir.
DN 5. Okay, so block 2. Okay, if you see DN 5, we have block 2 and block 3, correct? Yes or no, guys?
Yes, sir.
Okay. So now, okay, what is the status here? What do you mean of status? Okay. So now, what is the expected copies here?
3, sir.
Huh? 3. Okay. How many data nodes are representing?
3 data nodes, sir.
3. Okay. Status is okay. Okay. Now, okay. How many blocks okay, we have here? Okay. So what is the replication for second block?
3.
Okay. So how many data nodes are representing?
3
data nodes.
The status is okay here. Okay. Now for this one also, 3 copies and 3 data nodes. Status is okay. Okay. So here.
1.
1.
1. Okay. So 1 data node is representing. Status is okay. Okay. Here also replication is equal 1. 1 data node is representing. Status is okay. Okay. So now, so we understood this one, this table now. So who will update this table? Okay. So now, okay, let us take this scenario. Okay. Suddenly, if data node 1 is down, sir. Data node 1 is down. Okay. What will happen? If data node 1 is down, okay. So data node 1 will not send heartbeat to name node, correct?
Yes.
Yes, sir.
Okay. So in that scenario, what name node will do? Okay. So name node will remove data node 1 details. Okay. So here, okay, I will put here. So if equal to this one, then okay. Okay. Else, okay. If A greater than this, okay. Then the status, sir. Okay. Okay. Now you see here, guys. Okay, you see here. Okay. So here, now, if data node 1 is down, what will happen? If data node 1 is down, immediately name node will see wherever data node 1, okay, here it will remove that name. Okay, it will remove that entry. Where okay, so data node 1 name is available for block 1. Okay, delete it. Okay, then okay, where it is available?
Block 4.
Block 4.
Okay, it means it is a under replication. What do you mean of under replication, guys? What do you mean of under replication?
So it's copy node.
Copies, but okay, we have only 2 copies. Yes or no?
Yes, sir.
Okay, so whenever status is changed as under replication, or whenever status is not okay, okay, immediately name node will check. Why? What is the issue here? It says that the replication factor is 3, but only 2 data nodes are representing. Okay, so now what name node will tell? Okay, say name node. Okay, you copy this block 1 to data node 3, you copy this block to data node 4. Okay, now data node 3 will give the copy to data node 4. Okay, now in the next heartbeat, okay, data node 4 will send a heartbeat saying that okay, hey, I have data node 4 with, okay. So I have block 1 with me. It means, okay, now for block 1, okay, data node 4 reported that I have block 1 with me. Okay, immediately name node updated data node 4 here. Okay, now what is the status now?
Oh, it's okay, sir.
Okay, so now after some time, okay, suddenly data node 1 is started, sir. What will happen? Now data node will send a heartbeat, right? In that
Yes.
heartbeat, data node 1 will tell that, okay, I have block 1 with me. So now it will update, okay. So data node 1 here. Now what is the status, guys? What is the status? Over replication. Why over replication?
Because required replication factor is 3.
It is supposed to have 3 copies, but okay, now it is in 4 copies. Understood? It is supposed to be there only 3 copies, but okay, it is represented by 4 data nodes. In this scenario, over replication. Okay, so even when there is a over replication, one extra node will be deleted. Under replication means one extra node will be created. Okay, extra copy will be created. Okay, here extra copy will be deleted. Okay, so now question is that out of these 4, from where it will delete?
Is it node 4, sir?
Data node 4 only.
Latest one. Latest one.
There is no guarantee. There is no rule that okay, it should be deleted in data node 4 only. It can delete any copy. End of the day, I want to maintain 3 copies, sir. Okay. What is there for you? Okay. If I maintain in data node 1 to 3 or okay, data node 1 to 4. Got it.
Okay, sir, got it.
Who out of these 4, whoever is overloaded, from that overloaded machine, it will delete. Suppose okay, out of these 4, node 3 is overloaded. Okay, delete from node 3. Now status is okay. Out of this 4, okay, node 4 only overloaded. Delete from node 4. Now status will become okay. Understood. End of the day, so how name node will understand, okay, whether we have correct replication or over replication or under replication based on the status in the block report. The block report says that okay, under replication it will create extra copy. Over replication delete extra
It will
copy.
delete it.
Okay, understand this? Okay, so if data node 1 is back, okay, mostly will be deleted here. Okay, anyway, we have block 4 also here. For block 4, okay, we have data node 1. Now status is changing. Okay, got it. Okay, now maintaining this report is easy, right? Than changing this FS image file.
Yes.
Okay, again, okay, if I lost this report, is there any problem? If I lost this report, is there any
It should
problem?
not be a problem, Venkat, because anyhow it is reporting.
Because okay, so if I lost this report also, due to any reason, okay, if name node lost this report also, anyway, okay, within next 3 seconds, every data node will send the report again, right?
Yes.
Yes or no?
Yes,
Yes.
sir.
Every 3 seconds, okay, each data node will be sending this report. So if I lost this one now, okay, within 3 seconds I will recreate it. I means name node here.
Yeah, correct.
Yes or no? So it means okay. So this report, okay. So is it okay to lose this report? Is it okay?
No,
If I
sir.
lost this report, okay, you cannot reconstruct. Understand?
Yeah, correct. Yeah.
So this is important one. You cannot reconstruct. Okay. What about this one? If you lose this one, is it okay? You cannot reconstruct.
Yes.
You cannot
Yeah,
reconstruct.
correct. Work.
Okay. But okay, if you lost this one, can you reconstruct?
Yes.
Yes.
No, sir.
And
Because
every 3
Yes.
seconds.
Yes.
Because okay, so every 3 seconds anyway the same information is coming to name node, right?
yes, sir.
If I lost this one, okay, I will recreate it once again. Okay, this is fine. Okay, even if I lost this report also, no problem. That is the reason, okay, I put it in green color. Okay, and okay, now the last one is data node information file. Okay, what is this data node information file? Suppose, okay, this will contain information like, okay, so how much data we have in each data node. Okay, so how many data nodes we have? Okay, so what is the total storage in each data node? What is user capacity? What is okay? Storage? How many blocks we have. Okay, this is the information. Okay, this is the information. Okay, now even if I lost this information, is it okay? Anyway, next 3 seconds, okay, data nodes will send this information, right? See, every 3 seconds, okay, so every data node will send heartbeat to send
Name node.
to name node or every 3 seconds.
Every 3 seconds.
Okay, in this time, okay, what it will do? So data node, okay, will share, okay, storage information, okay, like, okay, so total used free storages, storage information, okay, okay, so storage information means, okay, data node info, block information, which is nothing but, okay, block report. Understood, sir?
Yes.
So it means, okay, so if I lost this report also, in the next heartbeat, okay, in the next 3 seconds, the data node will send heartbeat. In that heartbeat, okay, it will update, okay, how much total storage I have, how much use storage, how many free blocks, how many blocks, what is the status, and okay, it will update this information also, block report also. These are the blocks with me. Okay, so that is the reason, okay, even, okay, this also I will put it like 3-1. Okay, so here, okay, so here the red ones are the reports. Okay, so these are the 4 reports name node will maintain base. Okay, so block report. Okay, so whenever data node service is started, it sends the list of blocks it has to name node through heartbeat. Okay, so every data node, okay, will send okay, information like whatever the blocks they have. Okay, this information to name node. Okay, so name node receive the individual block information. Name node will receive. Okay, from, okay, now I have 5 data nodes. Okay, each data node will send this information, right?
Yes, sir.
Okay, so each data node, okay, report is called as an individual block report. So it means, okay, now if I have 5 data nodes, I have 5 individual block reports. 5 individual block reports will be sent to name node. Okay, what name node will do now? Name node will put it in a consolidated block report like this. Understood? Consolidated block report like this. Okay, so this is called as a consolidated block report. So each data node will send the individual block report. Okay, and the name node will receive it and it will merge into a single consolidated block report and maintain it into its own memory. Okay, so now where this file will be maintained? Okay, is it in hard disk or it is in memory?
It is in memory.
It's in
One
memory.
will be faster. Hard disk is faster. Memory is faster. Yes.
Memory is faster.
Memory is faster. Okay. So
Yes.
maintained only in memory. Okay. So this report will be maintained only in memory. Will you agree with me? Okay. And even data node information also. Okay. So here at the end. Okay. So along with these metadata files. Okay. Okay, name node also maintains the consolidated data node information file which contains available data nodes, allocated capacity, user capacity, remaining capacity, number of blocks from each data node. It means, okay, along with these 3 reports, okay, okay, name node will also have one more file which is called as data node information. Again, it is maintained only in memory. Okay, why these are maintained only in memory, guys? Because, okay, so if I shut down my machine, okay, my memory will be lost, right?
Yes.
Okay, so it means, okay, even if I shut down, okay, if I shut down, these reports will be lost. But even these reports are lost also, is there any problem? No,
No.
they can be reconstructed. Okay, so that is the reason these 2 reports are maintained only in memory. It means these reports will be there only in memory. Okay, only in memory. Okay, but when it comes to these reports, okay, FS image edit log. Okay, this is a report. Okay, so can I maintain, okay, in memory this one?
No.
Maintain
No, sir.
in
Hard disk.
Only in hard disk. Sir, no.
Yes.
Maintain only in hard disk. Okay. So only in hard disk. Edits also maintained in only hard disk. Okay. So here, okay, there is a question, guys. If I maintain this only in hard disk, okay, every time like a new file read operation is there, every time new file write operation is there, okay. The lookup is
Correct.
happening in these two files or not? Suppose okay, you're reading a file, sir. Okay, I want to read sample1.txt. Okay, so reading algorithm I will run the command. Reading algorithm will reading algorithm will contact name node. Okay, so now what name node will do now? Name node will check, okay, whether the file entry is metadata is available here or not. I want to read sample1.txt. Yes. Okay. Sample. Okay. So to check whether the file metadata is available here or not. Okay. So it has to name node has to open this file or not.
Yes.
So if like this, if there are 100 people trying to read some data 100 times, okay, name node has to open this file. Okay. So opening this file 100 times is not safe at all, right? That is the reason we introduced edit log. Okay. So for writing operation, okay, this is fine, but for reading operation also you are opening this file. Okay. So instead of opening this file so many times, okay, let us maintain one copy in hard disk, okay, and other copy in memory. Understood, sir? Huh?
Okay.
So what is the advantage here now? If I maintain one more copy in memory, if there is a lookup operation, we'll check in the memory content. Okay, but when there is a new file write operation, I will update in the hard disk. Understand?
Sir, the file stores in memory is only for reading operations?
Sir, okay, not for reading operations, sir. Here, okay, it works like this actually. Okay, so okay, it works like this case. So one copy of this file will be available in the memory also. One copy will be available in the
Hard disk.
okay in the hard disk also. Okay. Now coming back to this one. Okay, whenever you are writing a file, okay, so name node will open message image fs image and check whether the file entry is existing or not. Okay, it means it is checking for the existing entry, yes or no. Okay,
Yes.
so when it is checking, it will use in memory copy. Understood?
Okay.
Sir, in memory means it's in the RAM or?
RAM, sir, RAM.
Okay.
Okay, because okay, see whatever is in the hard disk, okay, the same copy available in the RAM also. Okay, so checking in hard disk, checking in RAM, both are same, right? In fact, okay, checking in hard disk again, okay, that will take a lot of time. Okay, so checking in RAM is very fast. So your lookup operation is happening on memory copy. Okay, but okay, so now, so here, name node open fs image and update the new file metadata. Okay, into edit log. Okay, so edit log. Okay. So now tell me, okay, in this scenario, updating the new metadata means okay. So this copy, both places it will be separate, right? Memory copy. Understood?
Yes.
Sir, no. Will you agree with me, guys? Okay, so if it is only lookup operation, it is doing only memory copy. Okay, but okay, when I want to update the new metadata, okay, I'll update in both the memory copy and hard disk copy. So that okay, tomorrow if you shut down your name node server also, okay, still okay, these two files will be available in the hard disk. Yes or no?
Yes.
If you shut down your laptop, okay, if I save a file into your laptop, okay, after restarting, can I see the same file or not?
Yes.
Yes, sir.
Sir, okay, see now this is the file sample1.txt. Okay, it is on my desktop. Even if I shut down my laptop and restart, will I see the same file or not?
Yes.
Yes. Okay. But what in case if I store this sample1.txt into memory? If I shut down
We
my
can
laptop,
we can last that sample 1.txt.
you will lose the sample1.txt. Correct?
Yes.
So, okay, so that is the reason what I'm doing. Okay, what name node is doing? It is maintaining one copy here in hard disk. Okay, and one copy in memory. For lookup operation, for read operations, it will check in the memory copy. Okay, for write operation, it will update in the hard disk. Okay, so now tell me what are the different files name node will maintain? FSMage, then it's block report,
data node
information. These are the 4 metadata files which will be maintained by name node. Okay, FSMage in memory and hard disk.
Yes.
No. And okay, edit log, memory and hard disk. Block report,
Only memory.
only memory. Data node information, only
Memory.
Clear now? Any questions?
We are good, Venkat.
You are good, right?
Sir, FSMage is not maintaining the data node information, right, sir?
Sir, inside FSMage, why data node information is required now? So we remove this information. That information is maintained here. Okay. Now, okay, can you tell me how read operation will happen? This. Okay, let's say I want to read sample1.txt, sir. Okay, as a user, what I will do? As a user, what I will do? I will execute the command. User run the command. Okay. Command will invoke. Command will. Okay. So here, okay. So Venkata is running a command. Okay. To read the file sample1.txt. Okay. The command will invoke what? Reading algorithm. Okay. Reading algorithm. This is the reading algorithm. Okay. So now what this reading algorithm will do? What this reading algorithm will do? Reading algorithm will contact name node. Yes or no?
Yes.
Reading algorithm will contact name node and ask, hey, I want to read sample1.txt. Okay. So now what name node will do? Name node will do the lookup whether the sample1.txt is available or not. Okay. So now metadata is available where?
In memory.
This image or edit log. Okay. So first, okay, which file it will check for sample1.txt?
In edit log.
But in edits, okay, do we have sample1.txt?
No.
Okay, now it will check in the FS image. Okay, so now sample1.txt is available. Okay, now okay, from this sample.txt, now it will take the block numbers. What are the block numbers for sample1.txt?
Block 1, block.
BLK1, BLK2, correct? Now,
Yes.
with these numbers, it will come to block report.
Yeah, that's what, sir. What in case, as since it is a memory location, when we are restarting the mission, we don't have the block information, right, sir?
Sir, okay, until, okay, suppose if this report is not there, okay, name node will recreate it within 3 seconds, right? So when you run a command before 3 seconds, okay, name node will make your command to wait until this report is generated.
Okay, sir.
Otherwise, okay, how, okay, name node will understand, okay, where is BLK1, where is BLK2. So to run your command, okay, so this report should be ready. Before running the command, this report should be ready. Correct or not?
Yes, sir.
Okay. If this report is not there, okay, how name node will tell that, okay, where is block 1 and where is block 2. Okay. So now from FSMage or edit log, it will check the metadata entry and it will take the block numbers. Then it will come here and it will see where is block 1, where is block 2. Where is block 1 and block 2?
Data node 1, 2, 3, sir.
Block 1 is in data node 1, 2, 3. Okay. Block 2 is in data node 3, 4, 5. It's okay. You can give this information to whom? Name node will take this information and give it to reading algorithm. It will give it to reading algorithm. Correct. Who is giving this information? To name node 1. So to reading algorithm. Name node is giving this information. Correct or not?
Yes, sir.
So now reading algorithm understood that block 1 is okay. So whatever the file you are asking, that is in divided into two blocks, block 1 and block 2. Okay. So now where is block 1? Block 1 is in data node 1, 2, 3. Okay. Now reading algorithm will ping data node 1, 2, 3. Whoever replied first, it will ask that data node. Okay. So hey, data node 1, can you give me block 1? So now think that, okay, out of these three, data node 3 replied first. So immediately it will reading algorithm will ask data node 3, hey, can you read block 3, block 1 from your storage and give it to me? Okay. Now data node 3 will read block 1 and give it to reading algorithm. So here, so I'm getting BLK 001 from data node 3. Okay. So this is the 001 from data node 3. Okay. So now block 2 is available in data node 3, 4, 5. Okay. Now 3, 4, 5. Okay. Okay. So now when reading algorithm ping these three nodes, so let's say 5 is replied first. Okay. Now it is asking data node 5, hey, can you give me block 2? Okay. So now block 1 is given by data node 3, block 2 is given by data node 5. Okay. Now so reading algorithm will merge these two blocks and okay, create a full entry, okay, full data in one entry or one file, and okay, that will print it on the screen. Understood, sir?
Yes, sir.
Okay. So do you think, okay, all these files are very, very important or not?
Yes.
Yes, sir.
Okay. All these are called metadata files. Okay. So these are the files that which will be used by name node. Okay. Anytime. Clear? Or any questions?
Clear, sir.
Sir,
Ah.
so whenever you entering the new files, it will goes to edit table, right, sir?
First edit, yes, sir.
So then it will merge into FS image.
Yes, sir. Our
So
limit.
it will update in within table, or it will create new new FS image table.
Okay, so that I will explain, sir. Okay.
Okay.
That I will explain in the next slide. Okay. But till now, any questions?
No, so clear.
Till now, everything is clear, right?
Yes.
Okay. Yes, okay. Think, okay, because okay. So these are very, very important. Okay, and okay, you should understand the connectivity between each and every file. Okay. What file, okay, will contain what information? This is important interview question also. What are the different metadata files maintained by name node? Okay. Clear?
Okay.
Yeah. Now, next question. Okay. How metadata is maintained by name node? Okay. So now you understood, right? Okay. So here, so FSMA edit logs are the physical files and stored on the hard disk and name node machine memory. And okay. So hard disk of the name node machine and okay, copy of the same will be maintained in name node memory also to serve all client requests effectively. Okay. So FSMA and edit logs are the physical files which are stored in hard disk, one copy, and memory, one more copy. But okay, block report data and information files are maintained only in memory and never saved to disk. Because okay, so why name node is not storing these files into disk? Because okay, these files can be reconstructed. Okay, if I ask all data nodes, if name node asks all data nodes, hey guys, send me your block report, everybody will send. Send me your free space information, everybody will send. So no problem at all. But okay, FS image file, edit log file cannot be reconstructed. Okay, so that is the reason okay, we are maintaining a copy of FS image edit log in the hard disk of name node. Yeah. Okay, so now what is checkpoint? Sir, Hanimi Reddy. Okay. Srinivaslu Pokuri. Please be on mute, sir. Okay, otherwise it will disturb entire class. Okay. Now next thing, guys. Okay, what is checkpoint? Okay, so here, okay, guys. Okay, I told right. Okay, here, okay, I told like okay, every 1 hour, whatever the metadata entries we have inside the edit log will be merged with FS image. Correct or not?
Yes, sir.
Yes.
Now, okay, checkpoint means the process of process that takes FS image and edits and merge into new FS image. This process is called as checkpointing. Understand? So checkpointing means it is a process which will take FS image, edit log and merge them into new FS image. This process is called as checkpointing. Any questions? Any questions, guys?
No, sir.
This task was automatically done, or
So now the question, now the point is that who will do this point? Who is responsible to merge these two files into new FS image? Secondary name node or standby name node. So as of now, we know only name node and data node, but now two more characters entered into our class. What are the new characters? Secondary name node or standby name node. So at this moment, you don't know what is secondary name node or standby name node, but you think that so these are two new characters in our class, and they are responsible for doing checkpointing process. Clear?
So these two are different or same? Same, right?
Different. When they are same, then I would have given only one name, right?
Okay. No, it's written R, so that's
it means two different people.
Okay.
It can be done by you or by me. Got
Okay.
it? Okay. So it means So now let us take this. What is checkpoint? So here checkpoint means so taking FS image. Merging of FS image. So FS image plus edits. So FS image plus edits is called as new FS image. Correct or not?
Yes, sir.
This is existing FS image plus edit log equal to new FS image. New FS image. So now if we take this one, so we have created a table, right? So let's say this is existing FS image. Existing edit log. Edits. New FS image. Edits. Existing FS image. New FS image. New FS image. Now time is 8 o'clock. Let's say it is a new cluster, guys, which we built at 8 o'clock. You build a cluster for the first time. Edits will be 0. Existing FS image also 0, and new FS image also 0. Understood? So yes, now time is 8:59. So now 8:59 means so from 8 o'clock to 8:59, there are some people created new files. So when they created new files, where that entries will go?
Edits.
Say new files are created. Now number of entries at 8:59 is 10. At 8:59, 0, 0. Sir, no. Now 9 o'clock. Time is 9 o'clock. So now what is the content of edit log?
0.
The content of existing FS image. 0, 1. New FS image? Sir, existing FS image still 0 only, but what is new FS image? So new FS image is edits plus existing FS image equal to, so edits plus new existing FS image both equal to, yes or no?
Yes, sir.
So now, time is 8:59. At 8:59, what is edits? So 9:59 time, let's say. There may be, let's say, 25 entries here. Now, what is existing FS image?
10.
10. What is new FS image?
0.
New FS image 0. But at time is 10 o'clock. 0.
10.
10.
25.
35.
Understood now?
Yes.
Understood, guys? Okay. So your 10 o'clock FS image will become existing image at 10:59. Correct or not? Correct or not, guys?
Yes, sir.
Okay. So now, so this process is called checkpoint. Okay. Now who will perform checkpoint? Okay. Checkpoint will be done by
Secondary name, no?
secondary name node. Or
Standby name.
named by name node. Okay. So here, okay. So when checkpoint will occur? Of course, okay. So checkpoint will occur. Okay. Secondary name node or standby name node perform checkpoint on below scenarios. Okay. So for 60 minutes or every 1 million transactions. Okay. So here the concept here is that it will perform secondary name node or standby node will perform for every 60 minutes. So again, I will put in Hadoop 1x 2x also. Okay. Hadoop 1.x. Okay. So it is every 60 minutes or 1 million transactions. This is the concept. Every 60 minutes or 1 million transactions. This is 1x. Okay. And again, in 1x, we don't have standby name. Okay. In Hadoop 2x, when it comes to Hadoop 2x, okay, or Hadoop 3x. Okay. Because every Hadoop version they are making some changes actually in Hadoop 3x. Okay. So we have so this time has been in 1x it is done by standby name secondary name node. In 2x it is done by this one, but every 360 minutes. What do you mean by 360 minutes, guys?
6 hours.
Every 6 hours. Okay. The checkpoint in 1x, the checkpoint will happen every 1 hour. In 2x, okay, the merging will happen every 6 hours once. Understand?
Yes, sir.
Any questions? Okay. In 1x, it will be done by secondary name node. In 2x and 3x, it will be done by standby name
Venkat, this part is not clear. See, new FS image is should be updated, yes. So in second case, it should be 35, yes. When because like whether it
node. So
edit.
this is 35, sir.
Yeah.
This is 35.
Okay, got it.
Correct right now?
Yeah, yes.
35, yes. Correct. Because so edits existing edits 25, okay, existing FS minus 10, both equal to 35. Yes. Clear now?
But one more question is like, see, anyhow, this is done by a secondary name node. But how this new FS image will be taken up by name node, active name node?
Yes, sir.
That
Yes,
is
sir.
another
Okay.
question. Yes.
Yes, sir. Okay. It will refresh automatically, sir. Don't worry about that. Okay. Understand?
Okay, got it. So it will refresh
refresh
automatically first in memory, then in hard disk. Yes, is it like that?
Exactly, sir. Exactly. Okay.
Okay, yeah, got it.
Yeah. Okay. So it means So secondary name node will perform the checkpoint in Hadoop 1x, but that is timing is every 60 minutes or 1 million transactions. Standby name node will perform checkpoint in Hadoop 2x and 3x. Okay, but it is every 360 minutes. It means a checkpoint will happen every 6 hours once. Okay. So now apart from this one here, what we are saying, name node also performs checkpoint. Okay. So this is every 60 minutes. Okay. Every 360 minutes. No?
Yes, sir.
This is every But here we are saying that so name node also performing checkpoint. Will name node also perform checkpoint? Yes. Okay. So name node also will perform checkpoint. Okay. So here, only during startup. Only during startup. Even only during startup. What do you mean only during startup? Tell me. See here, okay, name node is a service right here. What is name node here? It's a service, correct or not?
Yes, sir. So once when we start the service,
So you will, okay, see, some services will be started automatically, but some services you will have to start. Okay. Now here name node is not a service which will start automatically when you start your server. When you power on your server, when you log into your server. Okay. So you need to start. When you start the name node service, okay, that time it will perform checkpoint. Understand? So now tell me now, okay, in real time Office Hadoop clusters and all, okay. So how many times you will start name node and how many times you will stop data name nodes in a day?
I think so. It will be not on daily basis. I think so.
so very rare, sir. Daily we don't do.
Yeah. So sir, okay. Okay, like like our laptops and all, okay, you will not start the name node every day or you will not stop name node every day. Okay. So if you start name node today, okay, until there is an issue, name node will be keep on running 24/7, night, tomorrow morning. Okay. It means, okay, if I start name node today, maybe next 1 month also, the same name node service will be up and running if there are no issues. Okay. So you will not start or stop every day. Are you clear? If you start today, it may be up and running till it is stopped by you or till there is some issue. Got my point? Okay. So it means only startup. Okay. But okay, is it only startup time or every 60 minutes?
Only startup service.
Okay. So suppose, okay, let's say I started name node at, okay. So, well, okay, yesterday. Okay. So only yesterday it will perform checkpoint. Okay. But second name node?
Every 60 minutes it will be.
Yesterday 8 o'clock I started. Okay. Today it is 8 o'clock. Okay. In between, yesterday 8 o'clock, okay, name node will perform checkpoint. Okay. From yesterday 9 o'clock, 10 o'clock, 12 o'clock, 11 o'clock, 12 o'clock, 1 o'clock. Okay. Like that, okay, second name node will perform. Okay. Or if it is okay, in 2x or 3x, okay, standby name node will perform. Okay. So, but okay, so here 8 o'clock means, okay, from there 6 hours it will count. After 6 hours, it means you can add 4 times it will perform checkpoint. Okay. So this is performed by secondary name node. This is performed by standby name node, and this is performed by name node in all the 3 versions. Okay. Apart from this one, okay. So, okay, apart from this one, okay, you have an option. Okay, manual. So here, Hadoop admin will perform checkpoint. When Hadoop admin will perform checkpoint.
Sir, what is the main purpose of for this checkpoint, sir? Like, is it backup file for the FS image?
Sir, okay, main purpose means, okay, suppose, okay, if I don't merge edits into FS image, what will happen? One fine day, edits also will grow bigger, right?
Yes.
And then there is a chance of, okay, edits file corruption, right?
It's correct only.
That is the reason, okay, you are merging everything into FS image.
Yes, yes.
Okay. Yes or no? Okay. So these are the 3 things, okay, which will happen automatically. But okay, no, I am a Hadoop admin. I want to perform checkpoint now. Okay. On demand basis. Okay, Hadoop admin required when required. Whenever, okay, feel that, okay, fine, okay. So there is some issue. I want to perform checkpoint of name node. Okay. So you can perform checkpoint whenever it is required.
Sir, one question. So secondary name node or standby name node will be running on some other node, or will it be running on the same node?
Okay, I will come to that point now, sir. Okay, definitely these 2 services will be running on different nodes.
Sir, I have one doubt, sir, here.
Yes, sir.
Sir, is that secondary name node or the standby name node is same or different, sir?
They may, sir, if they are same, okay, then okay, I would have written, okay, one name only, na. These 2 are different, sir.
Okay, sir.
This service is in 1x only. Okay, it is not there in 2x, 3x. And okay, this service is there in 2x, 3x, not in 1x.
Okay, sir. Okay.
Sir, checkpoint procedure only happen for writing operations or both read operations also?
For any operation, sir. Let it be read or write. Okay. but checkpoint will happen.
Okay.
Sir, I have a question. Like
Yes,
for
sir.
one hour, edit log will be, moved to the, I mean, edit log will be copied, right? For every one to the name node. So what is the point of
Sir,
again?
edit log also, edit log FS image, all are in the same machine hard disk, sir.
Yeah. Sorry. Actually, what I'm saying is like for every 1 hour, edit log is moved to the FS image, right?
Merged with FS image.
Yeah, merged with FS. So what is the point of again FS image like? I mean, performing this checkpoint during the startup.
Sir, I said okay, every 1 hour it will happen, right? Who will do that? Who will do that? This service will do that every 1 hour.
Yeah.
If this service is not there, who will do it? Nobody will do it, na? Sir, is it automatic process or okay, somebody should do it?
For every 1 hour, it is an automatic process.
It's not automatic, sir. Okay, this service will do that. This service will do automatically.
Okay.
Got it. Sir, I'm saying automatic, right? Okay, even this automatic process also should be performed by someone, right?
Yes.
Yes or no? So it is an automatic process for Hadoop admin because okay, so there is another service okay, which will take care of this checkpointing. Okay. Automatically, so Hadoop admin no need to do anything. Okay, automatically, if Hadoop admin starts secondary named service, okay, this secondary named service will do the checkpoint every 60 minutes once. Got it?
Yes, sir.
Okay, so only Hadoop admin work is okay, starting the secondary name node. If it is stopped, okay, start it. That's the work. Okay, if that is there, it will take care of the process automatically every 1 hour. But if that is not there, it is not automatic process. It is a manual process. Understood?
Yeah.
Any questions?
Venkat, one question. In edit log is there, right? Every 1 hour from whatever the data is there in edit log, they are moving to FS image.
Whatever metadata is there.
Yeah, correct. No, is there every 1 hour is there? Here also there is any service or they are writing any trigger?
That is okay. This service, sir.
Okay.
Understand that work will be done by this service. If service is not there, that will not be done.
Okay.
Got it?
Okay.
Sir, sir, one question. In 2x, standby name node will work.
Okay.
And 1x, secondary name node will work. Right, sir?
Yes, sir.
Thank you, sir.
Yeah. And guys, okay, so one request, guys, okay. Suppose, okay, if you don't understand, okay, my answer, okay, see, not everybody will be good at English, okay. Until I start my training sessions, okay, I was very bad in English. Of course, now also I'm not so good in English, okay, but okay. So if you feel difficulty in asking question in English, please ask your question in your mother tongue, okay. But I don't know every mother tongue, okay, you know only, okay, English, okay, Telugu, Kannada, and Tamil. I can give it right, okay, and Hindi also. Okay, I can understand Hindi, but I cannot reply in Hindi. Okay, I'm very sorry for that. Okay, so if you feel okay to ask question in your mother tongue, you can ask in mother tongue. So even Hindi also you can ask in Hindi, but okay, I will reply. Okay, so these two things, okay, I'll reply in English only. To understand your question, okay, I can understand, but okay, to reply, I'll give in reply in English. Got it? Okay, so no problem. You can ask your question in Telugu, or you can ask your question in Kannada or English. Okay, so fine, right? Okay, so here you understood this process. Okay, now apart from this one, okay, so we have manual checkpoint. When I say manual checkpoint means okay, whenever Hadoop admin requires to do it, okay, whenever Hadoop admin to do manually, okay, he will do it manually. Normally, when it is required, sir, manual checkpoint, when it is required, normally.
When we go with the shutdown.
Suppose, okay, shutdown is one scenario. Suppose, okay, this secondary name node machine is having some hardware issue. Okay, to replace the secondary name node machine, it will take 2 days, sir. Within 2 days, who will do checkpoint every 1 hour?
Administrator.
In that scenario, Hadoop admin will do it manually. He has to run a command. Okay, to do the checkpoint, he has to run a command like okay, JFS admin equals save space. This is the command he has to run. Okay, this is the manual checkpoint command. Okay, but this operation to be performed by name node. Okay, so who will perform? Okay, he will execute the command. But end of the day, that command will be executed by name node. Got it? Got it, guys?
Yes.
Yes, sir.
Yes, sir.
Okay. So the next one. What is secondary name node?
Sir, as in your previous slide, you have written like it should be in safe mode or read only.
Safe mode, sir.
How
Yes,
we will place it?
okay, so it means okay. If Hadoop admin wants to perform the manual checkpoint, first he has to put the name node into safe mode or read only mode.
So from MRE or some GUI we can put it, right?
Okay, using some command. Okay, so you can put name node into safe mode. I will explain that okay clearly in the later slides.
Okay.
Yeah. Okay.
No, what is safe mode?
I will explain, sir.
Okay.
Those things I'll explain clearly later stages. Okay. Clear.
Sir, during startup means when firstly install, start the
No, sir.
cluster.
No. Whenever you are starting name node, sir. Suppose okay, so due to some issue, you shut down all the machines, sir. You created a cluster last week, sir. Okay. Due to some issue or wantedly, you shut down all the nodes. Now you are starting all the nodes. Okay. It is like you are starting name node. Correct or not?
Yes, sir.
That time it will perform checkpoint. That time it will perform checkpoint. Clear?
That means secondary name node is not available, then name node will perform checkpoint.
No, sir. No, sir. No. If secondary name node is not available, okay, sir, okay, let us take this scenario, okay? So you take this one, okay? So, okay.
Will perform.
Name
Hadoop
node.
admin will.
Okay? So name node. Okay. So here, okay, cluster started. Cluster started. Okay. Cluster started means, okay, cluster, okay. Services started. Services started means what under services started?
Name node and data nodes.
So name node started, okay, name node, okay. Data node, the nodes, okay, secondary name node is started. So at what time we started? Okay. So no, okay. 8 o'clock started. 8 AM. Okay. So at 8 AM, who will perform checkpoint? You are starting cluster at 8 o'clock. Okay.
Name node, sir.
Checkpoint. Okay. Now next checkpoint will happen at what time?
9 o'clock by secondary name node.
By secondary name node. Okay. Now 10 o'clock secondary name node. 11 o'clock secondary name node. Okay. Okay. Now 11:30. Now time is 11:30. Okay. So now secondary name node is down. Okay. Now next checkpoint. Okay. It is supposed to happen at 12 o'clock, right?
Yes, sir.
Yes or no?
Yes.
But 11:30 second name is down. Okay. 12 o'clock who will perform checkpoint?
Name node.
It is down.
Name node on.
Why name
Manual.
node will perform?
Manually need to be performed. Yes.
No checkpoint. Okay. No
Okay.
checkpoint here. Okay. Now again next 1 o'clock. 1 o'clock. Will checkpoint happen?
No.
No checkpoint. Okay. So now, okay, 13:30. Now 13:13. Okay, 13:30. Okay. SNN started. Now 14. Who will perform checkpoint?
Secondary name.
Secondary name node.
Okay, why name node? Okay, secondary name node. Okay. 15. Secondary name.
Secondary
16.
name.
Same secondary name node.
Okay. So now, okay, so this is all fine. Okay, so now, okay, 1630. Okay, 1630. Okay, 1630. Okay, name node stopped. Okay, 1630 name node stopped. Here. Okay, now 1645. Okay, name node started. 1645. Okay, what will happen? Who will do it?
Name node.
Name node.
Understand? Okay, again 17. Who will perform checkpoint?
Secondary name node.
Secondary name node.
Secondary name node. 18.
Same secondary
Sir,
name node.
how do we know that the secondary name node is down? How can we identify it?
There is a service. Okay, if you run a command, it will check whether it will tell you whether service is running or not.
Okay.
I will show you practical. When I started practical, okay, I will show you all those things. How to check whether name node is running or not. How to check whether data node is running or not. How to check secondary name node is running or not. I will show you. Clear?
Yes, sir. Clear.
So you understood right now? Clearly explained now. Every 1 hour, okay. So what's okay? Here all the services started. So that time, okay, name node will perform checkpoint. When name node is started, name node will perform checkpoint. Okay. So from there onwards, okay, every 1 hour, secondary name node will. But okay, here secondary name node is down. Okay. So no checkpoint, no checkpoint. Okay. But here, okay, when checkpoint is not happening, if Hadoop admin want to perform checkpoint, so he can do it. Since okay, secondary name node is not there, he can perform manual checkpoint. Okay. Hadoop admin. Understood now.
Yes, sir.
During this time.
Sir, only in absence of secondary name node, Hadoop admin will perform manual check.
Yes, sir. Otherwise, okay, secondary name node will perform automatically.
Yes, sir.
Why you want perform manually? Not required at all. Any questions? Okay. Now, okay, let us come back to this point. Okay, what is secondary name? When is a secondary name node? So secondary name node maintains a copy of FS image as a backup of primary name node's metadata. Okay. So what secondary name node will do? Okay, now the question is that where secondary name node will run? That is the next question. Okay. So here, okay, we see our cluster. Okay. I'll take this Hadoop cluster, same copy. Okay. Where secondary name node will run, we will see. Okay. So these are the things. Okay. So now, okay, secondary name node will run in a different server, server 6. Okay. Secondary name node. Understood, sir? Where it is running? Understood where it is running?
Yes, sir. It's running different server.
It's a different node.
So why they are running server? They are running in different server. Okay. So what secondary name node will do? Every 1 hour. Okay, every 1 hour. Okay. Every 1 hour, it will connect to name node machine. Okay. It will connect to name node machine and get a copy of FS image edit log. Okay. Bring it here. Okay. Bring these two here. Okay, so here, okay, so these are existing FS image plus edits. Bring it here, okay, and merge into new FS image.
New FS.
And push the copy of new FS image back to name node. name node. Understood now? Every 1 hour, what secondary name node will do, it will copy these two files from here to here and merge it into NewFS image. It will put one copy, it will push the copy to here. It means the NewFS image copy is available in name node as well as in secondary name node also. Yes or no? Why we are maintaining NewFS image in secondary name node? Because if NewFS image copy is deleted here, so here NewFS image. Okay, then this will be in memory as well as hard disk. So when a NewFS image is copied here, it will delete the old FS image now. When new is there, why you want old? You still want old? No, right?
Yes, sir. Right.
Okay. So like this, every 1 hour, the old FS image will be removed from name node server, and a new FS image will be kept into name node server by secondary name node. Understood? So this is a repeated process. Every 1 hour this will happen. Okay. So here, so name node, secondary name node will maintain a copy of FS image, new FS image here, as a backup copy. Okay. Tomorrow, if new FS image is down, I want backup copy, right? If for block, so your block, you're replicating that block. If this block is done, I can still read from this copy or this copy. Okay. But here, due to some reason, FS image is gone. From where you will get FS image? So FS image copy will be maintained in secondary name node. Clear? Clear? Or any questions?
Yes,
sir. Sir, you said every 1 hour, the secondary name node will contact to name node, right?
Yes, sir.
So it will keep maintaining the connection entire long session, or it will contact for every 1 hour?
It will contact every 1 hour, sir.
Okay. Okay. After transaction will completed, then it will automatically disconnected from name node.
Yes, sir. Yes.
Okay.
Yeah. Okay. So it retrieve FS image edits from primary name node. So if I take this as a primary name node, it takes a copy of these two from primary name node and merges and perform checkpoint. Checkpoint is merge them into new FS image regular intervals and put the latest copy of FS image back to primary name node. Okay. Primary name node. Okay. But in case of name node failed, writing algorithm or reading algorithm, contact secondary name node. So secondary name node will never act like a primary name node in case of primary name node failure. Okay. In case, if primary name node is failed, reading algorithm, writing algorithm will not work. Very simple. Okay. But they will not, since name node is not there, they will not contact secondary name node for the reading operation or writing operation. Okay. So secondary name node work is only performing checkpoint on regular intervals. Okay. There is no work, there is no direct contact between users and secondary name node. Got it?
Yes, sir.
Okay. So that is secondary name node. Okay. So we'll stop it here and we'll continue tomorrow, guys.
Sir, same is true for standby node, right?
Standby is different, sir. I'll talk about what is standby in later stages.
Okay, sir.
Okay. Clear?
Yes.
What is standby? I will talk later.
So if we are talking about secondary name node, then we are talking about Hadoop 1.x only.
1x, yes. So as I told you, I'll teach you 1x, 2x, 3x. Okay, because after completion of this course, you will put 3 years of experience. Okay. So they will ask 1x question, 2x question, 3x question also. Okay.
Yes, sir. Got it.
They ask what is the difference between 1x, 2x, 3x? Okay, so you should have the history, right?
Yes, yes.
Yeah, correct.
That's the reason I'm teaching you. Okay.
Thank you, sir. Yeah.
Okay.
One last question, Venkat, is like, do we need any special skills other than or this one is sufficient, or like kind of system admin skills for this, like admin, because
if you have good, sir, if you have good, otherwise my class, if you learn my class as it is, that's also more than enough.
Okay then.
Okay, guys. Okay.
Thank
Yeah.
you.
Thank you, guys. Okay, so